check. So let's go back and check. Okay, so we have math and we have 9. And we had the integral from 0 to 3. And this is from the absolute value. Of what was it? X squared plus 3x minus 4. X squared. I don't think this calculator deals nicely with the absolute value. I don't think it knows how to. Okay, so when we click enter, we should get this. Look at how much it's thinking. Okay, so let's see if it allows us to change this into a fraction. Nope, it's not. It's not good enough for absolute value. So I found a glitch in the system. So we found it. So 89 divided by, what was it, 6?
6.
Yeah. So it somehow it cannot handle absolute value too well. But now I want to verify one more thing with you. What if we do the work for this calculator? 0 to 1. Yeah. Yeah. So that will give us a different answer, I bet. Oh.
That probably won't take as much.
Okay, minus 3t and plus 4 and dt and then plus and math and number 9 again. And this was from 1 to 3 because I want the whole thing at once. And x. And the other one was t squared plus 3t and minus 4. Okay, and this, I bet I can change this into a fraction.
It looks promising.
Unbelievable. Unbelievable. It cannot handle absolute value, so don't use it. So it's 89 over 6 as we expected, but the other one had an error and he could not even change it into a fraction. Wow. So that's why knowledge is always important. Calculator cannot do everything. Okay, so the last little thing that I was going to show, and that is the end of the material for this semester, for Calc 1. Properties of the definite integral. So I didn't skip this. I just didn't consider it crucial when we were talking about integrals, but now I need to go back and finalize that. So I'm on page 12. Page 12. Okay. So the definite integral has many properties. And we listed those properties. But now I would like us to use them. I'll find them. So starting from here, use the properties of integrals to evaluate something like this. Well, we already know the fundamental theorem of calculus, so for this one, we know how to evaluate it. 57. Write as a single integral. We already practiced this property, but let's practice it again. So let's start with 57. So we have the integral from -2 to 2 from f of x dx plus the integral from 2 to 5 from f of x dx minus the integral from -2 to -1 from f of x dx. And they're asking us to condense these into one integral. So let's analyze what we see here. -2 to 2, and then 2 to 5, and these are added. So these two, the integral from -2 to 2 and the integral from 2 to 5, can be replaced, these two, right, by the integral from -2 to 5 from f of x dx. There is no question, right? These two, when we add them. But now they're asking us to subtract the integral on the interval -2 to -1. So when I add these two, I get the integral from -2 to 5. But now they want us to subtract this integral between -2 and -1. So what will be the final answer?
Like do the function.
So this integral,
So from integral of 2 to -2 to 5
exactly,
minus.
that's it. We already subtracted it. We added this 2 to get -2 to 5. And now we're subtracting this. So we're getting from -1 to 5 from f of x dx.
-1. Oh yeah, makes sense.
So let's make sure, let's do this again. From -2 to 2 is this piece.
Yeah.
From 2 to 5 is this piece. When I add these two together, I get this. The integral from -2 to 5. But now they are asking us to subtract this piece. The integral from -2 to -1. So what is left?
Oh, let's see. Yeah, we should be from -1 to 5.
The -1 to 5. So this is one of the properties. Subtracting, adding integrals. Good. If this is 37 and this is 16, find this. Let's do that. It's another property, 59. And we have if the integral from 0 to 9 from f of x dx, they say, is 37. And the integral from 0 to 9 from g of x dx is 16. They're asking us to find the integral from 0 to 9 from twice f of x plus 3 times g of x dx. Other properties we're implying here or using here. Good. So how do I write this integral? Well, I have the integral from 0 to 9 from twice f of x dx plus the integral from 3 g of x dx, of course, from 0 to 9. But I also write 2, the integral from 0 to 9 from f of x dx, plus 3, the integral from 0 to 9 from g of x dx. But this is given to us as 37. And this is given to us as 16. So the answer is 2 times 37, 74, plus 3 times 16, 48. So I got 122. How do you feel about this problem?
I think it's pretty simple.
Good. That's all I wanted to hear. Good. We already did this. Find the integral from 0 to 5. We already used 4 integrals already, right? So you will have the integral from what to what?
From 0 to 3.
Exactly, from 3, and then plus from
or from
3 to 5 of x. Yeah. Okay. Exactly. Good. More properties. 65 through 68. And that's it. That's the end of the course. use the properties of integrals to verify. Here, I don't have to verify. I can integrate. But here, I do not. I can integrate this one, but not this one. We don't know how to do it yet. You will in Calc 2. Same thing here, same thing here. So we want to just verify the inequality without evaluating the integrals. So let's choose whatever you want from 65 to 68.
We can choose 66. Oh,
60?
no.
Which one? It doesn't matter. You choose. So page 13. Say it again. Which one?
66.
66. Okay. Let me copy it and then stop sharing. So we have the integral from 0 to 1 from the square of 1 plus x squared dx. They say show that it's less than or equal to the integral from 0 to 1 from the square of 1 plus x dx. You can say, oh yeah, I'll plug them both in the calculator. This should be a smaller number than that, and I'm done. No. We want to illustrate using the properties of definite integral. So first thing we have to do is start with the basics. Identify the fact that x must be between 0 and 1. That's it. That's our starting point. These limits of integration specify basically that x is the variable that goes from 0 to 1. Okay, now let's start by building this. And then also by comparison. So let's see one thing. Can I add 1 to all three sides? Yes, I'm allowed to. We've done that many times. Can I apply the square root? Yes, because they're all positive and they're increasing, right? So I have the square of this, the square of this, the square of this. So 1 is less than or equal to the square of x plus 1, the square less than the square of 2. So I have an idea where is the square root of x plus 1 from. It's between 1 and the square root of 2. So I looked at that side. Now I would like to look at this side. So I still start with x between 0 and 1, but this one has x squared. Can I square everything? I can, because they're positive. 0 less than or equal to x squared, less than or equal to 1. Then, of course, I'm going to add 1. And I have 1 less than or equal to x squared plus 1 less than or equal to 2. So I didn't make a lot of headway. Why? Because, see, I got exactly the same thing. So 1 and x plus 1. So then, knowing that they are in the same range, I need to compare 1 plus x squared to 1 plus x. Which one must be smaller? Keeping in mind that x is between 0 and 1. So if I choose, let's say, 1/2, this is 1 plus 1/2, which is 3/2. But this one is much smaller. Why? It's because I have 1 plus 1/4. Because I have to square 1/2. It's a number between 0 and 1.
It's, yeah, between 0.
Exactly. So this is always going to be a number smaller than this one. Guaranteed. For x between 0 and 1, not for other intervals. But between 0 and 1, this quantity will be a smaller quantity than this. You can choose anything else. Let's say 1/3. 1 plus 1/3 is 4/3. But this is 1 plus 1/9, which is smaller than 1/3. So this will always be smaller than this. Again, for x between 0 and 1. So
What
now,
if it's like just 1?
I'm sorry?
What if it's, no.
If it's 1, it's 2. 2
Yeah,
is correct. Less than or equal to 2 is correct. So therefore, their square root will also be the same, in the same relationship. Once I have this is one of the properties. If a function is less than another function, the area under this graph must be smaller than the area under this graph between 0 and 1. And it's done. You don't have to show anything else. We showed that the 1 plus x squared is less than 1 plus x. We also showed that the square root of 1 plus x squared is smaller than the square root of 1 plus x. If I show this, one of the properties of the definite integral says if a function is below another function, the area under this must be smaller than the area under this, and you don't have to show anything else. Okay, so let's look at another. Let's choose one more. And I'm on page 14.
That is 68.
Okay. So 2 less than or equal to the integral from -1 to 1, 1 plus x squared dx less than or equal to the square root of 2. Okay. My starting point has to be the same. That's all I know. That x varies or goes from -1 to 1. Yes. Now we have to think. Look at the graph of -1 to 1. In other words, this is the interval. But I want to talk about the function x squared. For x between -1 and 1, look at the graph of x squared. Where does x squared go from?
X squared would go from 1.
For x between -1 and 1, x squared goes from what to what?
Same thing. Or it'd just be 1 to 1, right?
Look at the graph.
Yeah, it goes from 1 to 1, right?
Look at the graph.
Oh, just what? Like this.
What am I showing here? What value am I showing here for the graph?
0.
Ah,
Oh, it would be the same thing as just saying 0 to 1.
exactly. So when x is -1, the y value is 1. When x is 1, the y value is 1, but it starts at 0 to 1.
Oh, yeah, I get it.
Now, of course, we want to add 1 to all three sides. And of course, now we want to take the square root. It's positive, everything is positive, increasing, everything okay, safe. So 1 less than or equal to the square root of 1 plus x squared, the square root of the square root of 2. Excellent. Because we know a property when a function is between two constants, the integral from this, the integral from this, and the integral from this have to be in the same relationship. I have this in the middle. Now I have to calculate these end points, and I'm done. So when I calculate from this, I have x from -1 to 1. When I calculate from this, I have x the square root of 2 from -1 to 1. I plug in 1, I subtract when I plug in -1. So this is 2. 1 minus -1 is 2. The same thing here, 2 the square root of 2. And I'm done. So the left-hand side is 2, less than or equal to, in the middle, -1 to 1 from the square root of 1 plus x squared dx, less than or equal to 2 the square root of 2. And that's exactly what they were asking us to show. That the integral is some number between 2 and 2 times the square root of 2.